Hello, everyone. Welcome to another episode of Adventures in Machine Learning. Today we have Maria Zentsova on. She's an expert on building data pipelines and was kind enough to share some of her knowledge on KDNuggets, which is how we originally found out about her. So very excited to have her on. So Maria, who are you and why are you famous? That's our opening line.
Hi, Michael. Very happy to be here. So I'm a senior data analyst at Wood Mackenzie. It's a very small group of companies where we analyze a lot of data to build prediction models, analytics, and we also assess risks globally. For that, we work mainly with structured data. And in this article, I just wanted to explore how to extract intelligence from unstructured text data and to do it in more reproducible way with the data pipeline.
I remember working my tail off to become a senior developer. I read every book I could get my hands on. I went to any conference I could and watched the videos about the things that I thought I needed to learn. And eventually, I got that senior developer job. And then I realized that the rest of my career looked just like where I was now. I mean, where was the rush I got from learning? What was I supposed to do to keep growing? And then I found it. I got the chance to mentor some developers. I started a podcast and helped many more developers. I did screencasts and helped even more developers. I kind of became a dev hero. And now I want to help you become one too. And if you're looking forward to something more than doing the same thing at a different job 3 years from now, then join the Dev Heroes Accelerator. I'll walk you through the process of building and growing a following and finding people that you can uniquely help as you build the next stage of your career. You can learn more at devheroesaccelerator.com.
I just wanted to focus on one of this industry subset, which is clean tech. I just felt that maybe conversation around climate change can benefit from this central repository of all news and solutions that we have at our disposal. So for that, I collected RSS feeds from websites that write a lot about clean tech, clean energy, upcoming projects, and so on. And I used AWS as the primary tool, mainly because I wanted to experiment a little bit more with this, because at work we switch at AWS as well. And I thought building pet project would help me to get, more experience with this and bring this at work as well. So as for resources, I've used DynamoDB as a primary database. I've used AWS Lambda functions, and I used CloudWatch, obviously, for, tracking all of that. And I used SageMaker to build machine learning model and create SageMaker endpoint to use it in my Lambdas to generate predictions and summaries.
Got it. So you're using all sorts of crazy, awesome infrastructure. Let's take a bit of a step back. And can you state originally what this pipeline is for? So you mentioned it's about collecting news. Was this project dumped on you? Is it something that you're interested in? How did this project come about?
Yeah, so I just wanted to experiment, and I chose this problem of collecting news about clean tech. First step was to collect all websites that write about clean tech and the RSS feeds. RSS feeds is a structured feeds where publishers broadcast the URLs of the articles that they publish. So I created this DynamoDB table where I put all RSS feeds I could find. And the next step was to parse this RSS feeds, extract URLs, and send my scraper to go and fetch the full body of this text. And I also wanted this project to be this type of project where you can just see a summary of the news article. So you can decide whether you want to go and read in more details on the publisher website. But just to see the summary in just 1 or 2 sentences to get a preview of what this article is about. So once we have these RSS feeds, they come into different formats sometimes. Different publishers can publish this in slightly different ways. And so I found this feed parser library that allows to deal with all these different formats. So I didn't have to write these functions myself. So I chose to run this pipeline every 24 hours, but it can be changed. So in my pipeline, it's triggered by event trigger. And I set it up on every 24 hours. It's pretty easy to do in AWS and it's pretty easy to change. So if someone wants to do this way, it's completely flexible. Once this Lambda is triggered, it goes to DynamoDB and fetches all these RSS feeds. And why I chose Lambda is because it allows to do this like in a concurrent way. So I don't need to write some loops or anything. So I just send all these RSS topics to multiple Lambdas, and every Lambda takes URLs from this RSS feed. So that's how basically I go from RSS link to having a full URL of the article.
Got it. So you go from RSS that's stored in DynamoDB and you write a scraper to get the original text. I was wondering what scraper you use / how did you program it?
Yeah, so for that, I used Goose 3 library. It's quite an interesting library because when you fetch HTML web page with some scraper like Scrapey or anything, you would have to use some selector, like where the body of the page is located. But Goose 3 library uses machine learning to understand where is the text of the web page. And it gave me very good results on websites of various structure. So we just use this Goose 3 and extract the body of the text.
That sounds
very
awesome.
interesting. Yeah, very interesting. Like quirk of this website that I didn't know about is that some publishers, they broadcast URL of the article with the title, but there is no body of an article yet. And they write the body of this article maybe in an hour or several hours. And I had multiple cases where I go and to fetch the body of an article and I just get blank because it's not there yet. So that's how I understood that I need some capabilities to control the state of my functions and the whole this ETL pipeline.
Got it. And so when you go and extract this data with Goose 3, I remember back when I was doing some web scraping projects, I had to code out everything in Selenium. And that was hell because you have to actually specify the text box in the HTML and it will just copy that. There's a pop-up. You have to figure out pop-up handlers and all sorts of stuff. So the fact that this does this in an automated way is amazing. It makes me very happy to hear. And I was wondering if you had, so one common thing with news is there's lots of repostings on different sites. How do you, first of all, do you care about correct attribution to the original post? And if so, how do you go about that?
Yeah, so in my DynamoDB table, I save who is the publisher of this RSS feed. And this information basically goes to my summary. So that copyright belongs to this news publisher, and you can read full article on this link. And obviously, I couldn't save the full text due to copyright. So that is why I needed to process it and summarize in Lambda without saving it elsewhere, basically on my system.
Got it. So no original attribution, or is it included in there somehow?
Yeah, so it's included who copyright belongs to, and it's all saved in this DynamoDB table.
I see. So the RSS feed, there's only one unique original publish.
Yeah. So I go and use this original RSS feeds. But yeah, It's actually a very good question because, as you mentioned, the one article can be republished into different news feeds. And I think it's quite important to go to the original source. Also, I was quite lucky because this quite a niche industry, clean tech. So there are very specialized news publications and it's a little bit more business oriented. So there is no news aggregators and so on that can publish other content.
Yeah, that's a good point. So from the web scraping, you then enter into a nightly job that triggers Lambda functions. So can you explain what exactly a Lambda function is to those who might not know?
Yeah, so Lambda Functions is offering from Amazon that allows to run different scripts in a serverless manner. And what is really cool about this, I think it's very easy to get started. It's very flexible. And one of the key features for me was the ability to use it in a concurrent way. So to launch hundreds of Lambdas simultaneously. For instance, once I fetch multiple RSS feeds, I launch many Lambdas to go and parse each of those. So it's much quicker for a pipeline. And obvious drawback, it's hard to control it. I mean, hard to manage what we do if Lambda fails. And there are CloudWatch logs where you can see that Lambda failed, and they have very nice dashboard where you can track Lambdas. But I found that once I added more and more RSS feeds, it became really hard to manage and to observe the state of my pipeline. That is why I moved to our step functions, which allows to organize Lambdas into a serverless workflow. They call it a state machine, and it functions as a state. I already had all of my Lambdas, so it was quite easy to organize them into a pipeline by calling them by Amazon resource name. It is done by Amazon States language, which it took me some time to get used to this, but it's more like a JSON-like language where you call resources and organize them into this pipeline. So it really improved fault tolerance, for instance, because once I fetch URL from the website, I can't always get 200 response code. Sometimes it's unauthorized error, sometimes it's 404, and I had to deal with these cases. And our step functions allowed me to basically create a system. What do I do if something happens? And it's not like if something happens, it's when something happens. So obvious choice was to halt an execution of a pipeline, for instance, for one case. But sometimes I just refetched the full body of an article, like in an hour or in the 2 hours if it just wasn't there. So I really suggest to look into this, like other step functions. If you orchestrate your workflow with Lambdas, it's quite cool. It's also they show this tree of all Lambdas, how they connected and what state is it. Is it like successful or did it fail? So it's really improved like this observability of the system, and it's not very rigid. I could add additional steps. And one of the steps I've added was a text classification layer, because even though all these websites wrote about clean tech and companies that work in clean tech, it was still really difficult to filter out some news snippets that are just not relevant for me. For instance, if some company writes about its internal staff changes or so on, I didn't want this in this pipeline. So I needed to build this text classificator, if it is clean tech news or if this just news not about clean tech, but some irrelevant news. It's also became really important once I added some other websites which not really about clean tech, but which will write about this occasionally. I really wanted to add news about clean tech startups, like from TechCrunch and so on. But there are some other articles that just I had to filter them out. So I wrote this machine learning model. It was quite simple with BERT and a text classification layer on top. But one of the most big challenges for me, because I worked on this alone, and as I think anyone who starts this machine learning workflow without any data, it's really a challenge to create a big enough data set for deep learning. We all know that more data results in greater accuracy, but it's really hard to get our hands on lots and lots of data. So I was thinking how to do this, and I was inspired by a book, Practical Week Supervision. I think it got published in autumn last year, and they read a lot about Snorkel library. Snorkel library is developed by Stanford, and they open sourced it. Now it has like a commercial offering, but the core library is open sourced and everyone can use it. So in a book, they used it on fake news dataset to generate labels for fake news or normal news. And they describe it step by step. So I got like really inspired and wanted to use it for my use case as well.
That's really exciting. And I would love to dive a little bit deeper in just a sec, but how do you define relevance for news articles?
Yeah, that's actually a very good question. And I think the defining the problem in machine learning is skill as well. So in Snorkel, you have to label some subset of data manually. And once I started to label my data set, I thought that I want to show sustainability news. And once I labeled a few hundred of my examples, I realized I labeled them inconsistently. And that the problem is that I didn't define sustainability in a good way. So what sustainability is? So I went to UN website and then defined the sustainability goals. And I realized I label them inconsistently because first, I don't really understand it fully. And secondly, because it's very broad topic. And I realized I need to narrow down and define my problem in a very clear way. So I decided to focus on one subset of goals. It's climate change and clean tech. And they have a very clear definition of what clean tech is. So I took this knowledge to my labeling job and relabeled this few hundred points. So it was still a pain to relabel even a few hundred examples. And that's why it's really important to define the problem, what we want to do in a very clear way. So I ended up even writing down what the problem is, what do I do in any case? Like, for instance, if bioengineered meat is about climate change or not. So it really helped to, go further and do the labeling with Snorkel. So Snorkel allows to get domain knowledge about the problem and to encode it into a series of functions. So for instance, if we are talking about clean tech, we know that if news mention some solar energy, renewable, sustainability, there is a high probability that this news snippet is about clean tech. So there's like keywords. We can use keywords. I think many people who label text, I see a lot of articles about how they use regular expressions and so on to, bootstrap the data set. So Snorkel takes it to a little bit like a next level where we write specific functions and each function returns a label. They don't have to be 100% correct. And the idea is that we write a lot of these functions, and then Snorkel algorithms, they call them like voters. They have this majority voter method which we apply, and then Snorkel returns like what the label is most likely for this we can use for this data point. Also, it's really cool that you can use basically anything in this labeling functions. For instance, even another machine learning model. I ended up using GenSim topic model. So GenSim is a library that allows to build topic modeling workflows in unsupervised way. So I just dumped all the news I had and it returned what topics are there. So there were some clear topics like gaming, for instance, on some startup websites, cryptocurrency, and so on. So I knew that if it returns like gaming label, it's probably not clean tech. So I could use this machine learning model as an input into this Snorkel workflow. So also they allowed to use spaCy. Spacie as an NLP library. So for instance, we can write some functions like if this is an organization and it belongs to a list of organizations that work in clean tech, then it's probably clean tech as well. So I wrote a lot of those functions and they returned basically labeled data set, which was quite cool. I mean, I don't want to give an impression that it's like super easy. It took a lot of iterations. And I think the key there is to really pay attention to the data. That's why it's really useful to label at least like few examples, maybe a few hundred examples yourself, just to understand. And this in Snorkel, I think also really helpful to work with domain expert. If you label for like maybe for an area that you don't fully understand. So for instance, for clean tech, I really needed to read up on everything that is happening in this area to write correct functions. And it allowed me to improve accuracy.
Amazing. That seems like an incredibly useful tool. I was wondering how much confidence you have in its ability to generalize. For instance, theoretically, we could add a bunch of noise and it would pick up a lot of articles. Or we could be very conservative and just stick with very clearly sustainable goals and sustainable development articles. Did you think about the trade-off between the two?
Yeah, so I think I took more like conservative approach. So I followed the definition of climate change goal basically to the point, because I realized once I get, more broad definition of a problem, the accuracy really just plunged. But not because of Snork fault, my fault, basically, because I didn't understand full, like all these goals, how to encode them in functions. So that's why domain knowledge is really important, because you only can encode things that you know in this workflow. For instance, like you have to know what renewable energy news write about. So they write about solar energy, energy storage, and so on. And Snorkel allows to use their own machine learning model, or you can plug in some different model, but still, it didn't really improve results like substantially.
Got it.
But just to be honest, even if like a human labels data set, we also can't guarantee that the data won't be noisy, especially if the problem doesn't define very well. And if few people label data, you can end up with the situation where a different person understands it in different ways, and the data would be noisy as well. So yeah, just focusing a little bit more on defining what you want from the model, on clear problem definition, helps in any type of data labeling job, like quick supervision or manual data labeling, or outsourcing this to Mechanical Turk or anything.
Yeah, that makes sense.
Hi, this is Charles Max Wood from Top End Devs, and lately I've been coaching some people on starting some podcasts and in some cases just taking their career to the next level. Whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
And I was wondering, so we've created a beautiful training set using Snorkel, and then you said you fed it into BERT. I was wondering if you could speak a little bit more about how you trained the BERT model itself.
Yeah, I used TensorFlow for that and downloaded the BERT from TensorFlow Hub. And to be honest, it was like quite simple model. So we encode all our data using Bird autoencoder, and then I introduced a dropout layer and classifier on top. So first iteration wasn't really good because I didn't have lots of data first, and I trained my initial data set, initial model on TechCrunch news, and they have very particular tone of voice. So once I started to use this model on data from like more conservative industry news articles, I really saw a drop like in accuracy. So it didn't really perform well. So I think maybe it's quite often when there is drift in data and the accuracy changes. So, and I already had this definition of functions in Snorkel. So it was quite easy to dump more data into this label generation pipeline and generate more labels once I added more sources. So I think it's also one of the benefits of using this tool is that it allows to generate more and more data without manual labeling. And as I mentioned before, like my problem definition changed during the work on this. And if I were to label data manually, I would end up with a situation where I would have to relabel all of those news articles. But in Snorkel, I just modified my functions and I saw different results, different label result. So it was really cool. And I thought, yeah, I would need to use it for other projects as well. Also, there are like trade-offs. Obviously, if you work on some really critical machine learning model where you have to be sure in machine learning data, like 100% accurate, probably it's not the way to go. So yeah, so it depends on the use case.
Got it. That makes a lot of sense. And having the ability to be dynamic if the SLO or the goal of your modeling changes is a really attractive component because there are plenty of examples when business goals change or use cases change. And if you can just rerun something, like tweak a function that generates your data and rerun it, that's a really attractive component. And I was wondering, so you started off as a data analyst and worked your way up to building big bad machine learning models. I was wondering if you could walk us through that process, why you, first of all, were interested in data, and then just speak about the transition from data analyst to these more technical areas.
Yeah. Well, by background, I'm a geoscientist. And in geoscience, we also work with lots of data and use algorithms to, predict what is there under the surface. And I started as an intern in Deloitte, basically where I worked on various data sets. I really loved data and how they describe natural phenomena. And what's also interesting in geoscience is that you understand that you can't predict this with 100% certainty, that there is always some degree of, probability in your predictions. So I was really comfortable with this concept and when I started to work with data, when we describe like subsurface stuff, we have lots of tools that allow to deal with this big data sets. So if, for instance, we take all the oil wells that's drilled around the globe, you won't be able to open them in Excel. So it's inevitably introduced the need to learn some Python and to start working with this. We dealt with public data sets, and public data sets have a lot of minor inconsistencies. And the interesting thing is that they describe like natural things like subsurface layers under the earth. You can't always say if it's an issue in data or if it's a real life situation. So we used a lot of machine learning for that too. And I really got inspired by how you can solve problems by applying machine learning techniques. For instance, one of the most interesting for me projects that I worked recently was to predict how much carbon dioxide companies emit by using subsurface data. So if they operate a field, let's say like oil field or gas field, fluids have particular petrophysical properties which are not always known. So sometimes we wanted to predict these properties and calculate how much CO2 company emits. It's really difficult to do without machine learning. So that's how it's basically we needed to get into that.
Got it. What model did you use for that project?
For that project, we used this forest-based model. And one of the interesting, I think, inputs of this model was spatial data. And I don't know if you know, I really struggled to find examples where people use spatial data, like polygons, as an input to machine learning. We ended up generating like features from it, like the distance, is it within polygon or not? So like a little bit maybe hacky way, but it really improved the output.
That's crazy. So can you give an example of a polygon feature?
Yeah. So in geology, there are basically concept of geological basin. And I think geologists thought about machine learning, but not in a very standardized way. So there is a concept of like analogs. So for instance, if you know that this basin, let's say in Australia, has like the same type as a basin in States, probably they would kind of like behave in the same way. So this like concept of transfer learning, where you transfer what you know about this basin to unknown basin in different part of the world. So we introduced it as a feature in our model, like basically what type of the basin we are dealing with. And the model really improved once we introduced this feature. And these basins, they have shapes. It's basically a polygon type of data, and a field can be located inside or outside of this polygon. So we generated like this basically column in our tabular data set, which basin this field belongs to.
Got it. That makes sense. So you're trying to model the 3D aspect of basins. That's a cool problem.
Yeah, it was quite interesting, but it still was like, I feel a little bit hacky maybe. And I would love to see machine learning models that, use this spatial data sets. It would be quite cool, but I couldn't find, to be honest, any research into this.
Yeah, that's interesting.
Yeah, I think it can be applicable in a variety of situations, like even when you deal with user data, users can live in different districts. They can live like in a different distance from some infrastructure, like tube station or so on, and you can use it for predictions as well.
Got it. What is something about the intersection between data and clean tech that excites you?
Yeah, that's a very interesting question. I think that, climate change is clearly a problem. And I read up a lot about this, but I felt that the discussion around climate change can be more solution oriented. Maybe we can look at what solutions we have at our disposal to solve this problem. And this data, I couldn't find any data sets. There's a really clear project, Project Drawdown. They tried to categorize these solutions to climate change. And I wanted to basically notify about all companies that do exciting work in this space, exciting new projects, and just maybe to have more positivity that we have solutions. There are lots of exciting companies in this space, and so that people can see that a lot of people are working to solve this problem. But this data, they all hidden in this unstructured text data. So for instance, if you want just to see all companies that work in bioengineered protein, it's basically no way currently. Only if you go to some vendor, like analytics vendor. So I thought maybe it would be cool to collect this.
Got it. So you're looking for sort of an information sharing infrastructure, if I'm understanding correctly.
Yeah. Like the concept was, so we're a place where people can go and see everything that's happening in clean tech currently, what solutions we have, what projects are going online in the world, and what companies are working in this area. So I really want to work on this project further. It's a really cool project where you can test different things. So my next step is to introduce named entity recognition model, to extract companies that work in this area and places where this is all happening, and what are the biggest hubs of activity.
Yeah, that's definitely needed.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
I remember, so I studied environmental science in undergrad, and I remember seeing Project Drawdown, and it seemed like such a terrific solution. What they do is they provide not incredibly detailed, but pretty detailed steps for how to reach a different goal. Wow. So for instance, carbon neutral or things like that. And they have many different angles for it. So for instance, I'm very interested in marine energy, which is stick a wind turbine under the water. Mm-hmm. It spins and creates electricity. So there are tons of amazing solutions out there, but you're right that the clean energy sector especially is very fragmented for good reason. I think it's very challenging to standardize and collect all of this into one location. So you can do that. I will definitely be a consumer.
Oh, thank you. Well, I thought that there are so many different interesting solutions. And even though I read a lot about clean tech, I didn't know a lot of those. For instance, energy storage in a concrete, which is like crazy. So yeah, I think all, especially maybe decision makers in a government can also, benefit from this. I hope that it would be really helpful to collect this in maybe more standard way.
Yeah, I completely agreed. Do you have any advice for people looking to transition into this sort of energy and data/ML role that you've almost created for yourself?
Yeah, well, I think that domain knowledge is quite helpful. So for me, for instance, I'm data scientist, so it really helped to transfer this knowledge of, subsurface system to machine learning. Like, because when you do machine learning, you have to assess the result if it's correct, and you have to put some constraints in place in your training data, like generate features. So I think it's really interesting if you have some domain knowledge, not necessarily energy, any domain knowledge, for instance, medicine or bioengineering or marketing, anything. I think in a lot of those disciplines, there are problems that can be solved using machine learning. And it's really helpful to think about those problems you want to solve, try to phrase them as a machine learning problem, collect data. I think it's really helpful for machine learning specialists to collect data and to label data yourself. You will understand about the problem a little bit more, or you will understand that you don't understand the problem well enough. And then, use maybe simple algorithms at first, and then try to study more advanced concepts. For instance, when I dealt with news snippets, I really understood that I deal with data set that is where I need to undersample the majority class because it's just so imbalanced. And it forced me to go and study this in more details and use it in this model. So I also think that at work, what helped me is creating pet projects where I can study things like AWS or machine learning in more details, understand this in more details, and then I can use this knowledge at work when I feel more confident in these solutions.
Got it. So get some domain knowledge, collect and label your data manually, start off with simple algorithms and then work your way up to fancy ones, and then have side projects. Sound about right?
Yeah, that's what worked for me. I think people may approach it differently, but for me, going through whole machine learning workflow, starting with data collection really forced me to dive deeper into all these concepts because it's harder than just to deal with, ready-made data set.
Yeah, 100%. Cool. Well, we're about at time. Where should people go if they want to learn more about you or get in contact?
Well, I have LinkedIn open, so if you have any ideas, please drop a message. I will be happy to hear from you.
Sounds good. And we'll be sure to link the article in the show notes. Yeah, this was super fun. Thank you for sharing your wisdom. And
thank you so much, Michael. It was really great to have a conversation with you.
Of course. All right. Bye, everyone.
Bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.